Hello dear students, I am Dr Shikha Pandey, Associate Professor from Institute of Aeronautical Engineering. Today I will discuss you about the process of digestion, that is called as co-digestion. So before this lecture series of this solid waste management subject, I have discussed about the anaerobic digestion. So in continuation with the same lecture, I have discussed about the factors that are responsible for the anaerobic digestion. So today I will discuss about the co-digestion. So anaerobic co-digestion. So anaerobic co-digestion means it is like a simultaneous anaerobic digestion of a homogeneous mixture of two or more substrate to overcome the disadvantage of monodigestion and improve the economic viability of anaerobic digesters. So anaerobic co-digestion is same like the anaerobic digestion, but it is like a simultaneously reaction of two substrate and a homogeneous mixture of two or more substrate. So it will be helps to overcome the disadvantage of monodigestion and improve the mono digestion and economic viability of anaerobic digestion. So this anaerobic co-digestion is like a simultaneously anaerobic digestion process of homogeneous mixtures of two or more substrate that will overcome the disadvantage of monodigestion, and it will going to improve the economic viability of anaerobic digesters. And the uses of co-substrate improve the production of biogas and methane yield. Obviously, we are using one more substrate, so that substrate will helpful for the improvement of biogas production and methane yield. So the biogas production is basically like methane. Only methane is there. Many compositions are there, but mainly 75 to 80% of the biogas is methane only. So the uses of co-substrate, some other substrate will be used to make the homogeneous mixture of two more substrate. So this will helps in the production of methane gas, biogas enhancement and methane yield because of the two reasons. So it will increase because of these two reasons. First point is the establishment of positive synergism in the digestion medium. So synergism is a word that means two components mix up and they will enhance the reaction timing. That is called as synergism effects. So the two substrate mixed and that will gives a positive effect on the reaction. So with a mixing of two homogeneous mixture of two substrate, this will enhance the production of biogas and yield of methane. Next point is like optimal attainment of lacking nutrients from the co-substrate. So optimum attainment of lacking of the nutrients from the co-substrate and substrate which are having high CN ratio, monodigestion has poor process stability. So those substrate which are having good CN ratio means more CN ratio, monodigestion and it has a poor process stability. So anaerobic co-digestion is a simultaneously anaerobic digestion of homogeneous mixture of two or more substrate to overcome the disadvantage of monodigestion and improve the economic viability of anaerobic digesters. So next what happened? The addition of nitrogen-rich co-substrate at an optimum ratio enhance biomass degradation. So the co-digestion of different feedstock with animal manure can increases biogas production from 25% to 400% compared to the monodigestion of same substrate. So here it is an example. We can see that the comparison of this co-digestion process is like when we have a different feedstock with some animal manure can be added. So this animal manures, if we will add to a feedstock, this will be going to enhance the biogas production from 25% to 400% when we compare the monodigestion of the same substrate. So if digestion is there, substrates are there, if we will keep only animal manure, so their percentage is biogas production is like 25 to 30%. But when we add this animal manure to a feedstock that are having good amounts of nitrogen or carbon, so in this way it will enhance the production like 400% when we compare it with a single digestion process. That's why this co-digestion process is a very effective for production of the biogas and for the production of the methane biomass. Okay, so this is the example of this co-digestion of pig manure with glycerol. At a pig manure like glycerol mixing, what happened? 24 to 1% is there. So under mesophilic conditions, almost a 400 increase in biogas was observed in comparison with the conventional monodigestion of pig manure alone. So the in co-digestion of pig manure with some glycerol will be there, and that glycerol mixing will helps in the increase of mesophilic reactions, and almost 400% increase in the biogas was observed when we compare it with the conventional monodigestion of pig manure alone. So this will be an example of anaerobic co-digestion. So as this co-digestion will helps in enhancement of the digestion process, and the production of biogas will increase. So the methane production, obviously methane is the only component for the biogas. So methane production or biogas production will increased because of the positive effects of mixing of two substrate. So instead of using a single substrate, if we use two substrate, this will be going to enhance the production of biogas and the co-digestion of different feedstocks with animal manure. So if any feedstock will be there, so if we will co-digest it with the animal manure, like if we will add pig manure, if we will add cow manure, then automatically this will be increased. This will be causing positive effect on the anaerobic digestion process and the monodigestion of the same substrate. So we can see that this is an example of this co-digestion of pig manure with glycerol, and at a pig manure glycerol mixing ratio is a 24:1, and under mesophilic condition almost 400% increase in biogas was observed in comparison with the conventional monodigestion of pig manure alone. See, this will be like the advantage of this anaerobic co-digestion. So what happened? Benefits of anaerobic co-digestion. So first we will discuss about the benefits. So benefits will involve like dilution of toxic substances, then nutrient balance and synergistic effects on the microorganism. Next is the economic benefit. Obviously, if we will get good biomass, good biogas, then economic benefit is also there. Okay, then after increase OLR rate, obviously high methane yield on unit of digestible volumes. Let's discuss about its drawback. So drawback means what are the negative effects related with this anaerobic co-digestion. So increased digester effluent like COD. COD means chemical oxygen demand. Chemical oxygen demand is there. So it increases the inside the digester chamber, the effluent will be having more COD, and increase mixing requirement. Mixing requirement is also increased, and additional pre-treatment is required. As we discussed before this lecture, like pre-treatment is there for putting any substrate inside the anaerobic digestion chamber. First it will go through a pre-treatment. So obviously when we are going to add some more substrate, so that substrate will also need some pre-treatment. So this is called as additional pre-treatment requirement. Next is the economically critical and dependent on substrate cost and yield. So these four are the drawbacks that will be related with this anaerobic co-digestion process. So increased digester effluents. The effluent which is coming from the digester, it will be increased, like chemical oxygen demand is increased, and increased mixing requirements. Mixing requirements is also more. So if we will do the proper mixing, then only the process can take place. Additional pre-treatment will be required. Additional pre-treatment is that pre-treatment means the treatment of substrate before putting it into the digester. So the additional pre-treatment is also required. Economically critical and dependent on substrate cost and yield. So it is a very much critical, and it is basically dependent on the substrate cost and yield. So what is the cost of the substrate is much important, and if we will add that substrate, what could be the yield of that biogas digestion process. Now this is the conversion pathway during the anaerobic co-digestion process. So when we can see that this is a organic material is there, that is A. Another substrate we are going to use, this one is the B. So this is like another substrate, you can see that. and this substrate will be going to enhance the process. So pre-treatment is there. So first step is a pre-treatment. So either carbohydrate, protein, lipid and inert gas are there. So disintegration. So after the pre-treatment, obviously disintegration will be there. So with the carbohydrate directly it will go to the acidogenesis. So carbohydrate is broken into its a smaller unit that is called as monosaccharides. Like protein is going to be broken into its a smaller unit that is amino acids. Again for the lipids is also going into breakdown into a smallest unit that is called as long chain fatty acid. Next what happened, this monosaccharides amino acid is again going to break down into its smaller unit. So that will be involve the acidogenesis process. So acidogenesis process will cause the breakdown of these smaller unit into its some volatile fatty acid. So propylenic acid is there, butyric acid is there, valeric acid is there. Again in the process of acidogenesis will involve the breakdown of these volatile fatty acid into the acetic acids. So volatile fatty acid is going to be convert into the acetic acid. VFA will be converted into the acetic acid. You can see that. So this is the acetic acid only, and rest product will be like H2, CO2 will be there. Then again acetic acid will be break down into the methane and carbon dioxide by the process of methanogenesis. So here you can see that all the process of anaerobic digestion, that is hydrolysis is there, acidogenesis and acetogenesis, and next is the methanogenesis. And when you can see that this is the organic material B, this is the another substrate that we are going to be added into this process. So in either it will be a carbohydrate, or it will be a protein, or it will be a lipids or inerts. So disintegration process will be there, like the breakdown of these things, and then breakdown of these things will be going to be like some hydrolysis process will be there. So hydrolysis process is going to break down all these substrates into its smaller unit. So a smaller unit is like for carbohydrate, it's a smaller unit is monosaccharides, protein is like amino acids, then long chain fatty acid. This will be converted during the hydrolysis process. So after hydrolysis process, what happened? Acidogenesis step will be there. This acidogenesis step is going to break down these acids, these products into a volatile fatty acid. So what were these volatile fatty acid? This is the propionic acid, butyric acid and valeric acid. So these are the volatile fatty acid. So next step is that next step will involve acetogenesis process. Acetogenesis process will going to convert this all volatile fatty acids into acetic acid, or H2O2 will be coming out. Then the acetic acid will be converted into the methane and carbon dioxide. And this all will be like methanogenesis is the last process of this anaerobic co-digestion process. So this will be like conversion of this anaerobic co-digestion process. Here again we are adding the same organic material. So obviously this organic material will be there, that will be also going out throughout the whole process of anaerobic co-digestion. This organic material will involves many substrates. So that substrate is the some organic, some obviously some carbohydrate, protein, nitrogen or some inert material will also be there. So and before that pre-treatment will be there for organic matter A also, organic matter B also. For A pre-treatment will be there, for B disintegration will be there. So you can see this is the whole picture of this anaerobic co-digestion process. Anaerobic co-digestion process basically involves the addition of one more substrate into the traditional anaerobic methods. So that substrate will helpful for the enhancement of this anaerobic co-digestion process, and the production of biogas will be more, and this will be if production of biogas will be more, then this will be goes towards the production of more methane quality is also good. So biogas will get of a good quality methane, then the biogas will be more effective. So what now we'll discuss about the different factors they are affecting this anaerobic co-digestion process. So the chemical composition of the substrate. So substrates are there. So this substrate chemical composition is very important. So when we talk about the chemical composition of the substrate, first thing is the characterization of the chemical composition of different substrate is helpful to identify the appropriate substrate of anaerobic co-digestion. The characterization of chemical composition of different substrate. Obviously, first point is that it's a characterization. So substrate will be there, that substrate will be going for its characterization, and that characterization of chemical composition of different substrate will be helpful to identify the appropriate substrate of anaerobic co-digestion. So classifying the substrate according to their biochemical composition can be useful to evaluate the bioaccessibility, biodegradability and bioavailability of the substrate. So 3 points are there. The first one is the bioaccessibility, biodegradability and bioavailability of the substrate. So classifying the substrate should be classified according to their biochemical composition. There are different factors that affects the degradation of organic substrates such as bioavailability, bioaccessibility, temperature, pH, moisture, nutrient concentration. So there are some other factors also that is going to affect the degradation of organic substrate like bioavailability, bioaccessibility, temperature, pH, moisture content and nutrient content. So these are the different factors which will be responsible for this anaerobic co-digestion process. So this co-digestion process will be it will be connected with all the factors like the bioavailability of the substrate, then bioaccessibility, temperature of the substrate, pH, moisture content, then nutrient content of the substrate. Now, next we will discuss about the carbohydrate rich organic matter. If we are going to add or if the substrate livestock is having more carbohydrate rich organic matter, then what happens? So carbohydrate is present in all substrate in different portion. So any substrate if we are going to add, carbohydrate is already there because they are the food waste. So the food waste basically that will be coming from a sugar industry, fruits and vegetable processing is enriched with the simple sugars and disaccharides. So easily decomposable with the formation of volatile fatty acid. So they can be easily decomposable. Obviously food waste, any food waste that is coming from the sugar industry or fruits or vegetable processing is enriched with simple sugars and disaccharides. So easily decomposable with the formation of volatile fatty acid. So first, what is the problem with this carbohydrate rich organic material is that the high level of simple sugars will result into the rapid volatile fatty acid accumulation and decreases the pH and suppression of methanogenesis. So the high level of simple sugars are there because carbohydrate is there. So that will result into the rapid accumulation, rapid formation of volatile fatty acid and decreases the pH and suppression of methanogenesis. So its solution is that for balanced operation of anaerobic reactors, mixing the feedstock containing high amounts of simple carbohydrate with waste with a lower content of easily degradable organic components is recommended. So for balanced operation of this type of anaerobic reactor condition, the feedstock should be mixed with having containing high amounts of simple carbohydrate with waste with a lower content of easily degradable organic components is recommended. So it should be recommended that the substrate will having a carbohydrate composition should be mixed with the feedstock that will be containing more amount of simple carbohydrate and the waste with lower content of easily degradable organic components. Okay. Next is like a protein rich organic material. If the material is there which will be like a protein rich, then what happens? So during the all digestion process, the protein is converted to amino acid which are having an amine group. We know that NH2 is there. NH2 is there. So NH2 is the amine group, and amine group when the protein will break down it into its smaller part, that will be converted into the amino acid. And amino acid is nothing but that the acid that will be made up by amines like NH2 will be involved is called as amino acids. So the microbial degradation of protein results in the release of ammonium ions which are strong inhibitor of methanogenic bacteria. So microbial degradation will lead toward the protein results in the release of ammonium ions. This will be a strong inhibitor of methanogenic bacteria. So at high temperature, what happen? Ammonia is there, and that is going to inhibit microorganisms. And when the saturation at a concentration increases, it leads to process instability and system failure. So at high concentration, what happen? The ammonia inhibits microorganism. The ammonia is going to inhibit the microorganism, and when the concentration increases, it leads to the process instability and system failure. And it's a solution. What happen? If this type of condition is created inside the chamber, then what could be the solution that should be provided? So the suitable co-substrate that is going to adjust the CN ratio of its optimum value, or some culture enrichment in the system can minimize this problem. So the problem of related with this protein rich organic material is like what happened. Protein should be converted to amino acids, and amino acid is made up by the amine group like NH2. So the microbial degradation of protein will result in the release of ammonium ions. So that ammonium ions is a strong inhibitor of methanogenic bacteria. So if amine formation will be there, so they are going to inhibit the formation of methanogenic bacteria. So when the methanogenic bacteria will not form, then the methanogenesis step will not going to happen. Then it will be the substrate is not going to convert into the methane process. So this microbial degradation of protein will be results into the strong formation of ammonium ions, and these ammonium ions is the strong inhibitor of methanogenic bacteria. So the at high concentration, what happen? Ammonia inhibits microorganisms. The ammonia is going to inhibit the microorganisms, and when its concentration increases, when the concentration of ammonia increases, it leads to the process instability and system failure. So the ammonia concentration is going to be increased, so it will causes the instability and system failure. So what could be the possible solution? Solution is like a suitable co-substrate and adjustment of CN ratio to its optimum value, or cultural enrichment in the system that can minimize this type of problem, because the substrate which we are going to add will be having adjustment of carbon nitrogen ratio. So carbon nitrogen ratio will be make its optimum value or culture enrichment in the system, and it will be minimizing the problem. Next, if the substrate will be having fat rich organic material, so substrate with high concentration of fats or lipids causes blocking absorption of biomass, like causing mass transfer problem. So this mass transfer problem is caused by if a concentration of the substrate of the fats or lipid will be there, and the microbials is going to inhibit in anaerobic digestion. So the degradation of triglycerides produces long chain fatty acid and over 12 carbon and glycerols, and glycerol is rapidly converted to biogas, while decomposition of long chain fatty acid is complex. So high concentration of long chain fatty acid inhibits the activity of anaerobic microorganism that is causing the foaming, especially in elevated temperature, and produces toxic element. So here we are discussing about the substrate which are having fat rich organic material. So this fat rich organic material causes degradation of triglycerides that produces long chain fatty acid, and this long chain fatty acid and glycerol are there. Glycerol is rapidly converted to biogas. This glycerol is rapidly converted to fatty acid, and then it will be like long chain fatty acid will be there. So high concentration of long chain fatty acid inhibits the activity of anaerobic microorganism, and this will be causing foaming, especially at elevated temperature, and produces some toxic element. So the degradation of triglyceride produces long chain fatty acid and glycerols, and glycerols is again going to be rapidly converted to biogas, while the decomposition of LCFA, like long chain fatty acid, is very complex. That's why high concentration of long chain fatty acid inhibits the activity of anaerobic microorganism, which is causing the foaming, especially at elevated temperature, and produces toxic element. So it's a condition. What happened? This type of if fat fatty substrate if fat is more. Okay, so in this condition what it should be done? So what happened, the solution is that the mixing carbohydrate rich material with a fat rich material. Though see, if a more carbohydrate material is there, so that carbohydrate material should be mixed with the fat rich material, then the slow degradable and fast degradable. And our advantage is in nutrient balance, microorganism enrichment, reducing the accumulation of inhibitors, plus it is going to increase the reactor stability and improve the methane yield. So what we should do for this condition? We should mix with the fat rich material plus carbohydrate rich material. Carbohydrate rich material will be there. So they are mixing carbohydrate rich material with the fat rich material. Like, then what happened? The slowly degradation will be there, and the fast degradability will be there, and that will be helpful. That's advantage in nutrient balance, microorganism enrichment, reducing the accumulation of inhibitors and increasing the reactor stability. That is going to improve the methane yield. So next factor is the temperature. Temperature is again a very important factor in any of the anaerobic condition process. So the temperature, what it will do, like the microorganism grow best at temperature range of mesophilic and thermophilic. So the microorganism that is growing best, they grow best at the temperature range of mesophilic and thermophilic. And increased temperature increases the metabolic rate of microorganism and accelerates the digestion process. But thermophilic process is harder to control and needs more money to maintain the constant temperature of the reactor. So the increased temperature increases the metabolic rate of the microorganism. Temperature will be increases, the metabolic rate of microorganism is increases, and it is going to escalate the digestion process. But the thermophilic process is harder to control and it needs more energy to maintain the constant temperature of the reactor. Co-digestion process with a high concentration of ammonia is unstable in the thermophilic temperature range. So the co-digestion process with a more concentration of ammonia is unstable in the thermophilic temperature range. So the temperature range is also following a very important role for this anaerobic co-digestion process, because if the temperature increases, the metabolic rate of microorganisms accelerates and the digestion process. So the metabolic rate of microorganisms is going to accelerate or increases the digestion process. But the thermophilic process is harder to control. So the thermophilic process is harder to control and needs more energy to maintain the constant temperature of the reactor. And it will be required more time. This process will be harder to more energy to maintain the constant temperature of the reactor. So co-digestion process with a high concentration of ammonia is unstable in the thermophilic temperature range. Next condition is like pH. So the most favorable range of pH to obtain maximum biogas production is in anaerobic digestion is 6.8 to 7.2. The co-digestion can enable stable pH value by avoiding the extreme acidification condition. The co-digestion can enable stable pH value by avoiding the extreme acidification condition. The change in pH of the mixed raw material in co-digestion is more stable and easier to maintain in optimum pH range during the digestion process when we compare it with the single substrate digestion. So pH, here again we are discussing about the pH factors for this anaerobic co-digestion process. So the most favorable range for pH to obtain maximum biogas in the anaerobic digestion is 6.8 to 7.2. The co-digestion can enable stable pH value by avoiding the extreme acidification condition. The co-digestion is going to enable the stable pH value by avoiding the extreme acidification condition. And the change in pH of the mixed raw material in co-digestion is more stable and easier to maintain in optimum pH range during the digestion process compared to the single substrate digestion. The change in pH of the mixed raw material in co-digestion is more stable and easier to maintain in optimum pH during the digestion process when we compared it to the single substrate digestion. Next, we will discuss about the carbon-nitrogen ratio. So, most agriculture biogas plants they are having great potential for the renewable energy and technological improvement, but the direct utilization of agriculture waste by microorganisms is difficult because of their unbalanced CN ratio. Unbalanced CN ratio will be there, so this will be very tough because mostly agriculture waste will be having a great potential for renewable energy and technological improvement, but due to utilization of but only because of unbalanced carbon nitrogen ratio, it is very tough. So mixing the carbon rich substrate with nitrogen rich substrate, carbon rich substrate is mixed with the nitrogen rich substrate like animal manure and kitchen waste can improve the process stability, nutrient balance for microbial population growth and the biogas production. Mixing the carbon rich substrate with nitrogen rich substrate like animal manure with kitchen waste. So animal manure is like carbon rich substrate and it is mixing with the kitchen waste, so that is nutrient and nitrogen rich substrate. So both the substrate are mixed and it will be helps in the improvement of the process stability. So nutrient balance for microbial population growth and the biogas production. So the digestion process is stable at the optimum value of CN ratio in the range of 20 to 30. Digestion process is stable at the optimum value of CN in the range of 20 to 30. 20 to 30. This will be an ideal condition. So we know that the agriculture biogas plant will be having great potential for the renewable energy and technology improvement, but the direct utilization of agriculture waste by microorganism is very difficult because of their unbalanced carbon nitrogen ratio. And mixing the carbon rich substrate with nitrogen rich substrate, like with we will add the animal waste with the kitchen waste, and it is going to improve the process stability, nutrient balance for microbial population growth and the biogas production. If CN ratio is higher, then the digester buffer capacity become poor and producing large amount of volatile fatty acid during the fermentation process and lowering digester pH and inhibiting growth of methanogens. If CN ratio is low, the concentration of ammonia increases and inhibits the microbial growth of the system. So here we are discussing two conditions. First is like CN ratio is high, then the digester buffer capacity become poor and producing large amount of volatile fatty acid with the fermentation process and the lowering digester pH and inhibiting the growth of methanogens. If the CN ratio is low, then the concentration of ammonia increases and inhibits the microbial growth of the system. So two conditions are there, high and low. CN ratio is high, the digester buffer capacity become poor and producing large amount of volatile fatty acid during the fermentation process. Lowering digester pH and inhibiting growth of methanogens. Like if it will be low, then the concentration of ammonia increases and this will be like inhibits the microbial growth of the system. Here this is the data for different substrate categorized into lower and higher value of CN ratio. So relatively low CN value are these are first one is like they are having low CN value materials like cow dung, poultry manure, pig manure, sheep dungs, and like fruit and vegetable waste, horse manure, kitchen waste, food waste, peanut shoots, waste cereal, some grass, trimming, alfalfa, slaughterhouse waste, goat manure, mixed food waste. These all are having less CN ratio. And on the other side, the CN ratio of these things like the agriculture waste like rice straw, wheat straw, sugarcane bagas, corn stalks straw, oat straw, sugar beets, foliage, fallen leaves, seaweeds, algae, sawdust, potato. They are having high CN value and high CN ratio. So we can mix this with a low CN value material with a high CN value material. So here is this process will explain that what different organic material for anaerobic co-digestion system of biogas. Different organic materials are there, that organic materials, how it will work. So it is the, you can see this is the anaerobic co-digestion reactors are there. So in this mixture will be there. So household buy some product, slaughterhouse waste, some alpha greens are there, animal manure are there. Then we are going to selecting the substratum, what substrate we have to use to balance these things. So agriculture byproducts, some fallen leaves, algae, seaweeds and sawdust. So these are, the pink color is like, this should be added to maintain the CN ratio. These are the all like a food waste. Okay, this is the food waste, and this will be the agriculture waste or agriculture byproducts. So agriculture, so you can see that we are selecting the substrate, which substrate should be added. So it will be added into the mixture, then it will goes toward the anaerobic co-digestion process. Then digester will be there, then biogas storage. This is the biogas storage here. In this way, we are maintaining the CN ratio 12 to 35. And this will be anaerobic digestion process number 1, where the anaerobic co-digestion reactors are there. From mixture, it will be enters into the anaerobic co-digestion reactors. So you can see that they are having low CN ratio like 12 to 35. And these agriculture waste are having very high CN ratio 40 to 500. So different organic materials for anaerobic co-digestion system of biogas productions. So these are the some of the references which I have used for this lecture. And if you want to do the depth study of these topics, you can go to this textbook. You should be prefer this textbook for the depth study of all these topics. So now I am concluding the lecture at this point because it's over. Anaerobic co-digestion. Today I have discussed about the anaerobic co-digestion. So anaerobic co-digestion is the process of adding one more substrate to the anaerobic digestion process, and that substrate will be helpful in the enhancement of the for the biogas production, for the methane production, and the biogas which will having a good amount of methane. That's why those, if it will be lacking, if CN ratio will be not maintained, then we'll add this type of substrate that is going to be maintain the CN ratio. If the substrate will be having more carbohydrate, then we are adding the substrate that will be going to balance the carbohydrate ratio. Like that, for any substrate, we are adding one more substrate that is going to balance the other substrate. So now this will be like this. Anaerobic co-digestion process is very much effective, and we can take a very good percentage of biogas, and the biogas is having a good amount of methane also. So if you have any query, if you have any question regarding this lecture, you can write in the comment box, or you can directly mail me onto my mail ID, that is shikha.panday@gmail.com. So thank you for today's lecture.
Like, share and subscribe. Hit the bell icon for more updates.